A blessed morning, dear students. Welcome to another session of Valenzuela Live Mathematics 7. We are now in week 7 of quarter 1. For today's lesson, we are going to have a lot of computations to make. So please prepare your pen and paper where you can write your solution. Also, try to recall how to multiply whole numbers and decimal numbers by applying multiplication skills in our lesson for today. Our lesson for today is estimating the square root of a number. Based on the most essential learning competencies set by the Department of Education, at the end of this session, you should be able to estimate the square root of a whole number to the nearest hundred, and plot irrational numbers up to the square roots on a number line. For our first activity, let us see how much you remember our lesson last week about the principal root and irrational numbers. All you have to do is to determine between what two consecutive integers each of the following number lies. Are you ready? You have 5 seconds to write your answer in our comment box below. First number, square root of 7. 5 seconds, go! If your answer is between 2 and 3, then you are correct. Next number, square root of 28. 5 seconds, go! All right, the correct answer is between 5 and 6. Next number, negative square root of 45. 5 seconds, go! If your answer is between negative 6 and negative 7, then you are correct. Next number, square root of 104. 5 seconds, go! The correct answer is between 10 and 11. Last number, square root of 155. 5 seconds, go! If your answer is between 12 and 13, then you are correct. Now, consider the following sets of numbers. Set A containing the elements 1, 4, 9, 16, and 25. Set B containing the elements square root of 7, square root of 28, negative square root of 45, square root of 104, and square root of 155. What kind of numbers are 1, 4, 9, 16, and 25? What will happen if we get the square root of these numbers? If we take the square root of these numbers, the answer will become whole numbers or positive integers. All right, they are perfect square numbers. And what are perfect square numbers? Perfect square numbers are numbers produced when you multiply a certain number by itself. Take note that when we get the square root of a perfect square number, the answer is a rational number. Let us now consider the examples in set B. How would you describe the radicand or the number under the radical symbol? All right, they are not perfect squares. What happens when we get the square root of a number which is not a perfect square? What kind of number is produced? Let us now consider square root of 7. If you are going to use your calculator, it can display the following figures. 2.6457 and so on. Your calculator can display 8 to 14 digits only, depending on the calculator you are using. And if you are going to use your cell phone, it can display even more number of digits than a calculator. But if you use computer, it can display infinitely many digits after the decimal point. Now, how are you going to describe these numbers? All right, it is not rational. And what about decimal? Yes, it is non-terminating, non-repeating decimal. Numbers having the following characteristics are called irrational numbers. And what are irrational numbers? Irrational numbers are numbers which cannot be expressed as a quotient of any two integers. Take note that the numbers in set B are examples of irrational numbers. For example, square root of 7. Since we cannot get exact value of square root of 7 in decimal, we get only what we call an approximate value. Estimation is the process of finding an estimated value or approximate value closest to the given number. Instead of using the equal sign, we use the symbol double tilde, read as is approximately equal to, in giving an estimated value. Now, how do we approximate the value of the square root of a number up to the hundredths place without using a calculator? Let us have example number 1. Find the approximate value of square root of 7 up to the hundredths place. Again, this time we are not going to use a calculator. We're just going to follow the following steps. First step, determine between what two consecutive integers the given irrational number lies. Thus, square root of 7 is between 2 and 3. And why 2 and 3? Because the perfect square number before 7 is 4. The perfect square number after 7 is 9. When we get the square root of 4 and 9, we get 2 and 3 respectively. Second step, plot the irrational number on a number line. This will help us estimate its decimal value. Consider the location of square root of 7 in the number line. Since square root of 7 is closer to square root of 9, which is 3, than square root of 4, which is 2, then we just plot the point a little bit closer to 3 than to 2. It will also give us a hint that the number on the tens place is more than 5, probably 6 or 7. Let us take a closer look on the irrational numbers with the integer radicand between 2 and 3. So, the irrational numbers with the integer radicand between 2 and 3 are square root of 5, square root of 6, square root of 7, and square root of 8. Take note that irrational numbers behave differently in such a way that the distance between the consecutive irrational numbers with integer radicand is not the same with other consecutive irrational numbers. For example, the distance between square root of 4 and square root of 5 is not the same with the distance between square root of 5 and square root of 6. So with square root of 6 and square root of 7. Unlike with rational numbers, say 0 to 1 is 1 unit. 1 to 2 is 1 unit. They have equal distances. Third step, calculate the approximated decimal number by determining the fractional part of the distance of the irrational number from the integer number just before it out of the total journey of the irrational numbers in between the consecutive integers. In our example, there are 3 irrational numbers with integer radicand from square root of 4 to square root of 7. And this is somehow 3/5 of the way from square root of 4 to square root of 9. Thus, we can say that the square root of 7 is approximately equal to 2 as the whole number. Then to get the decimal part for our numerator, just subtract the integer radicand of the given number, which is 7, and the integer radicand with the lower perfect square, which is 4. So we have 7 minus 4. Then for our denominator, simply subtract the integer radicand with the greater perfect square, which is 9, and the integer radicand with the lower perfect square, which is 4. So we have 9 minus 4. So, simplifying 7 minus 4, we have 3, and 9 minus 4, we have 5. Hence, square root of 7 is approximately equal to 2 and 3 over 5. Now, how are we going to convert 3 over 5 in decimal? Remember, to convert a fraction to a decimal, we will just divide the numerator by the denominator. So in 3 over 5, we're going to divide 3 by 5. 3 will be placed inside the division symbol as the dividend. Then 5 will be placed outside the division symbol as divisor. To keep dividing, we're going to add a decimal point and a 0 after 3. Then we will also add a decimal point and 0 on top. Now, we can divide 30 by 5. 30 divided by 5 is equal to 6. Then we're going to multiply 6 by 5. 6 times 5 is equal to 30. Now, we will subtract 30 from 30. 30 minus 30 is equal to 0. Hence, 3 over 5 is equal to 0 and 6/10. So that means the square root of 7 is approximately equal to 2 and 6/10. But since we have to approximate up to the hundredths place, we will proceed to the next step. Fourth step, choose a digit from 0 to 9 to place on the hundredths place. Whichever is closest to the given number when the decimal number produced is squared. Since our first estimate is 2 and 6/10, we can choose from 2 and 61/100 to 2 and 69/100, whichever is closest to 7, when this number or when these decimal numbers are squared. But I will choose, say, 2 and 63/100. If I were going to square 2 and 63 hundredths, this means that I will multiply 2 and 63 hundredths by itself. And how do we multiply decimals? All right. Reviewing your skills on how to multiply decimals, we need to multiply these numbers just as if they were whole numbers. Line up the numbers on the right, then starting on the right, multiply each number in the top, which is the multiplicand, by each digit in the bottom number, which is the multiplier, just as with the whole numbers. So we're going to multiply 3 by 263. 3 times 3 is 9. Then 3 times 6 is 18. Bring down 8, then carry 1. Then 3 times 2 is 6, plus 1, we will get 7. Next, we're going to multiply 6 by 263. 6 times 3 is 18. Bring down 8, then carry 1. Then 6 times 6 is 36, plus 1, we have 37. Bring down 7, then carry 3. Then 6 times 2 is 12, plus 3, we have 15. Next, we're going to multiply 2 by 263. 2 times 3 is 6. Then 2 times 6 is 12. Bring down 2, then carry 1. Then 2 times 2 is 4. Plus 1, we will get 5. Now, add all the partial products. Bring down 9. Then 8 plus 8, we will get 16. So bring down 6, then carry 1. Next, 1 plus 7 plus 7 plus 6, we will have 21. Bring down 1, then carry 2. Next, 2 plus 5 plus 2 is 9. Then 1 plus 5 is equal to 6. Since in our factors, we have 4 decimal places after the decimal point, we're going to count 4 units from the right going to the left. So we're going to place the decimal point between 6 and 9. Thus, the value of the square of 2 and 63 hundredths is equal to 6 and 9,169 10,000s. So that's already close to 7. So let's try another decimal number. For instance, the square of 2 and 64 hundredths. Will you get your pen and paper and try to multiply this number? If your answer is 6 and 9,696 10,000s, then you are correct. That's pretty close to 7. Let's try another one. The square of 2 and 65 hundredths. Will you solve this one on your paper? All right. Were you able to get 7 and 225 10,000s? That's great. Now, let us compare the values that we obtained. The square of 2 and 65 hundredths has already exceeded to 7. But which of these two values is closer to 7? Again, let's compare. We're going to find the difference between 7 and 6 and 9,696 10,000s. Then we will have these following figures. Do you still remember how to subtract decimals? In order to subtract these figures, we're going to add a decimal point and 4 zeros after 7. Then we can now subtract. We're going to borrow 1 from 7. then the rest of the zeros will become 9, except the last 0, it will become 10. So we have 300 for 10,000. Did you get the same answer? All right. This one has around 300 difference with 7. Now, let's take a look on the value of the square of 2 and 6500, which is 7 and 225 10,000. So if we're going to subtract 7 and 225 10,000 by 7, we will obtain 225 10,000. So what does it mean? This value has around 200 difference with 7, which is lesser. Therefore, we can say that it is closer to 7. Thus, we can now conclude that the square root of 7 is approximately equal to 2 and 6500. Let us now proceed with example number 2. Find the approximate value of square root of 28 up to the hundredths place. To solve this problem, again, we're going to determine between what two consecutive integers this given irrational number lies. But before that, we need to find the perfect square numbers nearest to 28 first. 28 is located between 25 and 36. All right. Now, getting the square root of these numbers, we will obtain 5 and 6 respectively. Square root of 25 is 5 and square root of 36 is 6. It means that the square root of 28 is between 5 and 6. Also, square root of 28 is greater than 5 but less than 6. Therefore, square root of 28 is approximately equal to 5 point something. Now, how are we going to determine this decimal part? Let's proceed to the next step. Plot square root of 28 on the number line. Since square root of 28 is closer to square root of 25, which is 5, then square root of 36, which is 6, then we will plot the point a little bit closer to 5 than to 6. Let us take a closer look on the irrational number with integer radicand between 5 and 6. As you can see, there are 3 irrational numbers with integer radicand from square root of 25 to square root of 28. And there are 11 irrational numbers with the integer radicand from square root of 25 to square root of 36. This is somehow 3 over 11 of the way from square root of 25 to square root of 36. But again, take note of this. We can get the fractional part by simply following these steps. For our numerator, just subtract the integer radicand of the given number, which is 28, and the integer radicand with the lower perfect square, which is 25. So we have 28 minus 25 is equal to 3. Then for our denominator, simply subtract the integer radicand with the greater perfect square, which is 36, and the integer radicand with the lower perfect square, which is 25. So we have 36 minus 25 is equal to 11. Hence, square root of 28 is approximately equal to 5 and 3 over 11. Converting this to decimals, we will get 5 and 27 hundredths. But take note, this is just the first estimate. We need to check if the value is still closest to square root of 28. So checking if 5 and 27 hundredths is the closest estimate to the value of square root of 28. We have the square of 5 and 27 hundredths. Try to multiply 5 and 27 hundredths by itself. What is its product? Very good. We will obtain 27 and 7,729 10,000. Let's take another one. What about 5 and 28 hundredths? What is its square? All right. It's 27 and 8,784 10,000. Let's try another one. What about the square of 5 and 29 hundredths? Will you try to solve this one? Were you able to get 27 and 9,841 10,000s? If yes, then you're doing great. Let's try another one. What about the square of 5 and 30 hundredths? Will you try to multiply it? All right. We will get 28 and 9 hundredths. Now, looking at the given values, we can clearly say that the square of 5 and 29 hundredths is the closest to 28. Therefore, square root of 28 is approximately equal to 5 and 29 hundredths. Let us now proceed with the last example. Mr. De Jesus' house has a square floor area of 155 square meters. If the side of the square is computed using the formula S is equal to square root of A, where S represents the side of the square and A as the area of the square, find the measure of the side of the floor of Mr. De Jesus' house. To solve this problem, we are going to use the formula S is equal to square root of A. Substituting the given floor area, which is 155, so we will have S is equal to square root of 155. Now, how are we going to approximate this number? Using the 4 steps earlier, square root of 155 is greater than the square root of 144, but less than the square root of 169. Therefore, the square root of 155 is greater than 12, but less than 13. 12 is the square root of 144, and 13 is the square root of 169. At this point, we can say that the whole number part of square root of 155 is 12. It is approximately equal to 12 point something. Then for the fractional part, for our numerator, just subtract the integer radicand of the given number, which is 155. And the integer radicand with the lower perfect square, which is 144. So we have 155 minus 144. Then for our denominator, simply subtract the integer radicand with the greater perfect square, which is 169, and the integer radicand with the lower perfect square, which is 144. So we have 169 minus 144. Simplifying this one, we will have square root of 155 is approximately equal to 12 and 11 over 25. And converting this value into decimals, we can say that the square root of 155 is approximately equal to 12 and 44 hundredths. But we are not yet done. We still have to check if the estimated value is already closest to 155. Check if the square of 12 and 44 hundredths is already closest to 155. So, what have we got? Will you try to solve this one? All right. We will get 154 and 7,536 10,000s. That's a little bit far. Let us try another one. What about the square of 12 and 45 hundredths? Try to solve it on your paper. Very good. We will obtain 155 and 25 10,000s. What does it mean? It means that it is very close to 155 because the difference is only 25 10,000s. While the other one, we have almost 2,500 10,000s. Again, looking at the given values, we can clearly say that the square of 12 and 45 hundredths is the closest to 155. Therefore, S, which is square root of 155, is approximately equal to 12 and 45 hundredths. For our final answer, we can now say that the side of the floor of Mr. De Jesus' house is approximately equal to 12 and 45 hundredths meters. Are you ready for the next activity? All right. Activity number 2. Choose only the letter of the correct answer. You have 5 seconds to key in your answer in our comment box below. Make sure to take note of the letters of the correct answer and every number for you to be able to decode our word of the day. Let's begin. Number 1. Between what two consecutive integers the square root of 75 lie? Is it letter R? Between 7 and 8? Is it letter S? Between 8 and 9? Or is it letter T? Between 9 and 10? 5 seconds. Go! If your answer is letter S, then you are correct. Number 2. Which of the following is the closest estimate for the value of square root of 104? Is it letter P, 10 and 18 hundredths? Is it letter T, 10 and 20 hundredths? Or is it letter B, 10 and 22 hundredths? 5 seconds. Go! Very good. The correct answer is letter T. Number 3. What integer is between square root of 115 and square root of 135? Is it letter U, 11? Is it letter S, 12? Or is it letter B, 13? 5 seconds. Go! your answer is letter U, then you are correct. Number 4. Which of the following irrational number is represented by point M? Is it letter A, square root of 95? Is it letter S, square root of 79? Or is it letter D, square root of 67? 5 seconds, go. Very good. The correct answer is letter D. Number 5. The area of Juana's square living room is 50 square meters. What is the measure of the side of the living room of Juana? Approximate the answer to the nearest hundred. Is it letter T, 7 and 2,500 square meters? Is it letter R, 7 and 1,600 square meters? Or is it letter Y, 7 and 700 square meters? 5 seconds, go. If your answer is letter Y, then you are correct. Did you remember the letters of the correct answer in every number? Can you now decode our word of the day? I'll give you 5 seconds to key in your answer. Go! Time's up. The word of the day is study. Remember, study hard. No matter how difficult our situation is, no matter if it's quite impossible to finish the race. If given the opportunity to study, don't waste time. Study hard anyway. You deserve a better future ahead of you, and you can achieve it if you study hard. So some of the important points of our today's lesson: estimation or estimating is the process of finding an estimated value or approximate value closest to the given number. Estimation is used to identify the value of the nth root of a number, specifically if the number is not a perfect square. We use the symbol double tilde, read as is approximately equal to, in given an approximate value instead of equal symbol. Irrational numbers are numbers that cannot be expressed as a quotient of any two integers, and their nature as decimal is that they are non-terminating and non-repeating decimal. Thus, this place value never ends. So what we do is just give the approximate value. The ability to plot an irrational number on a number line will help in calculating the estimated value of the irrational number. Let us now proceed with the question and answer portion regarding our lesson today. If you have any question, just type it in the comment section below, and our teacher moderator will take note of them. We are just going to answer a few questions, but don't worry. For sure, your subject teachers are there to answer your queries on your follow-up discussion tomorrow. For the first question, what is the importance of getting the square root of a number? And when and where do we need to use it? Okay, since getting the square root of a number is included in the most essential learning competencies, there is a need for you to master this concept. Why? First, for you to pass this grade level. Second, the concept of square root of a number will be applied in your higher grade levels. Say, for example, in grade 8, wherein you will be dealing with factoring polynomials. In grade 9 and 10, wherein you will encounter different formulas in algebra and geometry, like quadratic formula, distance formula, Pythagorean theorem, problems involving areas, and many more. All these make use of estimating square root of a number. Even in field of work like engineering, carpentry, masonry, architecture, they use square roots for measurement and calculation. For the second question, what if the given is negative square root of a number? For example, negative square root of 45. How to estimate it? Okay, you can use the same steps earlier since it still satisfies all the properties of square roots of positive numbers. For the third question, how to estimate the square root of a number having a negative radical? Remember, the square root of a negative number does not exist among the set of real numbers. For example, square root of negative 7. The square root of a negative number is defined as imaginary or a complex number. And this is beyond the scope of this lesson. For now, we can say that the square root of a negative number is not a real number. And for the last question, is there another easy way to get their square roots? Okay, if you're asking for a single formula that you can use to get the square root of a number, there is actually none. But there are other strategies that can be used in estimating the square root of a number. Your subject teacher may share with you other strategies tomorrow in your follow-up discussion. The strategy that I presented to you is just one of them. Just bear in mind that most of the strategies in estimating square roots require repetition of steps to get the closest estimated value. Thus, your skills in performing the fundamental operations for whole numbers, fractions, and decimals will be applied a lot. For your assignment, answer what's more exercises. Try this and keep trying. Quarter 1, Lesson 7, page 33 on your SLM. And that ends our discussion for today. Always remember, anuman ang sitwasyon, tuloy ang edukasyon. Thank you and God bless everyone. Keep safe.